Okay, welcome back. Now we can move to the next question. Question number one. We all in Kuppi class part one. We have already discussed about part A question. Now we are moving to the next B question. The B question is the specific heat capacity. We have to find the specific heat capacity of the gas at constant pressure. Constant pressure. They have already said that they they maintain the temperature from 15 degrees Celsius to 250 degrees Celsius, 15 degrees Celsius to 250 Celsius. Uh, at pressure of the gas remains constant. Pressure of the gas remains constant. Now we can move to the next question. This is a very simple question. Uh, uh, we already know this equation. We have already learned an A level overall time. Q is equal to m c into delta t. This is the main equation. Q is equal to mc into delta t. Now the question is we have to find the specific heat capacity. Specific heat capacity of the gas content at constant pressure. Therefore, this is the standard equation. Q is equal to mc into delta t. Mc into delta t. Now we already know Q is the heat transfer. Heat, we already know Q is heat transferred. 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 We already know Q is a heat transferred. M is a mass of the gas. Mass of the gas. C is the specific heat capacity. Specific heat capacity of the gas. Delta T is the temperature difference. But we must know that this Q is heat transferred. In some the if you find in some books you will find this equation like that, Q is equal to mc into delta t. But in some questions, some books in some engineering books you will find the equation like delta q. Delta q is equal to mc into delta t. They will use delta q. The reason is delta Q is the heat transfer. If we move the temperature from 15 degrees Celsius to 250 degrees Celsius, we have to increase. We have to give energy as heat. We have to go give energy as heat. No, therefore, uh, the Q is really the difference. How much energy should be? How much energy or heat you must uh, we must input to the uh, gas to increase the temperature. Therefore, some delta Q, but I found you use this equation. Q is equal to mc into Q is equal to mc into delta T. Now C is equal to Q by C is equal to Q by M into uh, C is equal to Q by M into delta T. They have already given. We substitute CB instead of C because C is C means this specific heat capacity of the gas. We use P for constant pressure. We find the specific heat capacity of the gas. We find the specific heat capacity of the gas at constant pressure. Therefore, I use this small p, Cp for constant pressure, small p or capital P. Cp is equal to Q. They have already given the Q. Where is the Q? This is 175 kilojoule. Uh, we give 175 kilojoule to raise its temperature. Therefore, the Q, the energy transferred is 175 kilojoule. That is the Q is equal to this is P. Q is equal to 175. 175 is 175 kilojoule. Therefore, say 175 into 10 to the power 3 joule. 175 into 10 to the power 3 joule divided by m. What's the mass of the gas? They have already given. The mass of the gas is where is 0 by 9 kilogram. This is there 0 by 9 kilogram. Therefore, mass is 0.9 kilogram. 0.9 kilogram into then we delta T. What's the temperature difference? The temperature difference is we move from 250 to 15 degrees Celsius. Delta T is T2 minus T1. Ne? Please wait. Okay, now you can see the screen now. Sorry for your time. Now, 175 10 to the power joule divided by 0 by kilogram into T2. What is the T2? 250 degrees Celsius. 250 degrees Celsius. Therefore, 250 degrees Celsius is we already have find that 523. 523. 523.15 Kelvin. Kelvin. Kelvin minus 523.5 Kelvin minus what is the initial temperature? Initial temperature is 15 degrees Celsius. Our 15 degrees Celsius is equal to 188. Sorry, 288. 288.15 Kelvin. Now is very simple. We have to if we calculate the equation, finally we will get the results for specific heat capacity at constant temperature is equal to 0.0.8274 0.8274 kilojoule kilogram minus 1 Kelvin minus 1. This is the final answer. This is the final answer. Now in next video we can discuss about parts equation. Thank you.